Hello, in this video I'll be working through Unit 3 homework problems 56 through 70. And for these problems we want to find the derivative. 56, j of x equals the natural log of e to the 2x plus 1. So we want to find j prime of x. And we're going to use our natural log rule. So this is in the form of the natural log of stuff. So derivative of natural log of stuff is 1 over stuff times the derivative of the stuff. So it'll be 1 over the stuff, e to the 2x plus 1, times the derivative of e to the 2x plus 1, which is e to the 2x times 2. So this is a double chain rule problem. Our first inside function is the e to the power 2x plus 1. And then when we take the derivative of the inside, that also has its own inside function, which is the 2x. So if we're going to work this out the long way, we can identify our inside function, u, as e to the 2x plus 1. And then our outside function is y equals natural log of u. So we find du dx, and that's to find the derivative of e to the 2x plus 1, we have to use the chain rule again. Okay, so this time I'm going to do the chain rule part in my head. I know the derivative of e to the stuff is e to the stuff times the derivative of the stuff. And then the derivative of 1 is 0. Okay, so then I find the derivative of my outside function, my dy du. So the derivative of natural log of u is 1 over u. And u then gets replaced with e to the 2x plus 1, because that's what e is equal to in terms of x. So e to the 2x plus 1. So now my final answer, I have to multiply these two derivatives together. So I get 1 over e to the 2x plus 1 times e to the 2x times 2, which is the same answer we got on the left. If I want to simplify this a little bit more, I mean, really can't simplify it more, but I can rewrite it so that it's just numerator over denominator, the 2x plus 1. 57, f of x equals the natural log of 3 minus 2x. Okay, so if I'm doing this in my head, I'm thinking this is in the form of natural log of stuff. So the derivative, f prime of x, the derivative of natural log of stuff is 1 over the stuff times the derivative of the stuff. And the derivative of 3 minus 2x is negative 2. So this is going to be negative 2 over 3 minus 2x. Okay, if we're working it out the long way, we can identify our inside function, u, equals 3 minus 2x, and then my outside function, y, equals natural log of u. Then I would find the derivative of u with respect to x. The derivative of 3 minus 2x is negative 2. And then the derivative of y with respect to u, so the derivative of natural log of u with respect to u is 1 over u. And u equals 3 minus 2x, so that's 1 over 3 minus 2x. And then we multiply these two derivatives together to get dy dx. So negative 2 times 1 over 3 minus 2x, which gives us negative 2 over 3 minus 2x. Same answer we got on the left. 58, k of x equals the natural log of the square root of 5x minus 2. I want the derivative, k prime of x. So this is in the form of natural log of stuff. So the derivative of natural log of stuff is 1 over the stuff times the derivative of the stuff. But now when I go to take the derivative of square root 5x minus 2, I need to use chain rule again, because this has an inside function and an outside function. The inside function, or the stuff, is the 5x minus 2. Okay, so now I'm asking myself, what's the derivative of the square root of stuff? Well, that's 1 over 2 root stuff times the derivative of the stuff. And the derivative of 5x minus 2 is 5. So now putting all of the parts together here, when we multiply in the numerator we get 5. In the denominator we get 2 times the square root of 5x minus 2 times the square root of 5x minus 2. So 2 times the quantity 5x minus 2, which is 5 over 10x minus 4. Okay, if I'm doing this the long way, showing all of the steps, my inside function u is the square root of 5x minus 2. Then my outside function y equals the natural log of u. So I want to take the derivative of u with respect to x. But here, to take this derivative of the square root of 5x minus 2, we have to use chain rule again. So if you're starting to get lost, let's just come down here and find the derivative of the square root of 5x minus 2. Okay, so I'm just doing this as side work. I want to know what is the derivative of this. So this has its own inside function. Here u equals 5x minus 2 and y equals the square root of u. So the derivative of u with respect to x equals 5. The derivative of y with respect to u equals 1 over 2 square root u. And in this case, the u is 5x minus 2. So 1 over 2 times the square root of 5x minus 2. And then we multiply these two together to get our derivative. So when we multiply that together, I'm going to get 5 over 2 times the square root of 5x minus 2. That's the derivative that I'm looking for right here. So that's 5 over 2 times the square root 5x minus 2. Then I still need to multiply by the derivative of this outside function. dy du up here is the derivative of natural log of u with respect to u. So the derivative of natural log of u is 1 over u. And in this case, my u equals the square root of 5x minus 2. Okay, so now we have to multiply these two derivatives together to get our final answer, dy dx. So it's 5 over 2 times the square root of 5x minus 2 times the square root of 5x minus 2, or just 5x minus 2, which gives us 5 over 10x minus 4. 59 t of x equals the natural log of x over x minus 2. So we have a function divided by another function. We want to use quotient rule. For quotient rule, we start with the derivative of the top. The derivative of natural log of x is 1 over x. We multiply that by the bottom, minus the top times the derivative of the bottom. And the derivative of x minus 2 is just 1. So here I'm just multiplying by 1. I'm not going to bother to write that. Over the bottom function squared. Now to simplify this, I have a complex fraction. That's a fraction within a fraction. So to simplify, I'm going to multiply the numerator by the LCD, which is x, and then multiply the denominator by x. So I'm really just multiplying by x over x, which is 1. Now I need to distribute that x to both of these terms in the numerator. Now when I multiply 1 over x times x minus 2 times x, I just get x minus 2. Minus, and then I'm going to multiply the x by the ln x, x ln x, over, and then on the denominator I multiply the x by the x minus 2 squared. I don't have any like terms in my numerator, so this is all that I can do to simplify this. Number 60, y equals arc sine of 5x. So y prime, or dy dx, equals the derivative of arc sine of stuff. This isn't just arc sine of x, it's the arc sine of 5x. So we need to use the chain rule here. Arc sine of stuff, the derivative of arc sine stuff is going to be 1 over the square root of 1 minus the stuff squared. And don't forget your parentheses there. Times the derivative of the stuff. And the derivative of 5x is 5. Okay, so this is 5 over the square root of 1 minus 25x squared. If we want to see that worked out the long way, our inside function, we identify that as u equals, so the inside function here is 5x, and then y equals, that's my outside function, y equals the arcsine of u. So we take the derivative of each of these with respect to their independent variables. So we have du dx equals 5, and we have dy du equals 1 over the square root of 1 minus u squared. U in this case is 5x, so that becomes 1 over the square root of 1 minus, and then 5x in parentheses squared. Okay, so then we just multiply these two derivatives. That's chain rule. So dy dx equals 5 times the 1 over square root 1 minus 25x squared. Y equals arctan of 1 minus x. We need chain rule here as well because it's not just the arctan of x, it's the arctan of other stuff. So dy dx is the derivative of arctan of stuff. And the derivative of arctan stuff is 1 over 1 plus stuff squared, like so, times the derivative of the stuff. And the derivative of 1 minus x is -1. So my final answer, -1 over 1 plus 1 minus x squared. If we want to see it worked out the long way, our inside function u equals 1 minus x, and then y equals arctan of u. So du dx equals -1, and dy du equals 1 over 1 plus u squared. Since u is 1 minus x, that's equal to 1 plus 1 minus x squared. And then we multiply these two derivatives. So dy dx equals -1 times 1 over 1 plus 1 minus x squared. And you could expand the denominator if you wanted to, but there's no need to do that. Y equals sine inverse of 3x squared. So this is in the form of sine inverse of stuff. We need chain rule here since it's not just sine inverse of x. So our dy dx is the derivative of sine inverse of stuff. The derivative of sine inverse stuff is 1 over the square root of 1 minus the stuff squared times the derivative of the stuff. And the derivative of 3x squared is 6x. So this will be 6x over the square root of 1 minus 9x to the 4th. If we want to work it out the long way, our inside function, u equals 3x squared. Then our outside function, y equals sine inverse of u. We take each of these derivatives, so du dx equals 6x. Then dy du equals 1 over the square root of 1 minus u squared. Since u is 3x squared, that gives 1 over the square root of 1 minus 9x to the 4th. And then we multiply these two derivatives together, and we'll get the same result we had on the left. Y equals tan inverse 3 over x. We want our derivative, dy dx. And this isn't just tan inverse of x, it's tan inverse of stuff, so we need to use the chain rule here. The derivative of tan inverse of stuff is 1 over 1 plus stuff squared times the derivative of the stuff. So now I have to take the derivative of 3 over x. So we have some options here. I can keep 3 over x as is and use the quotient rule, but that's a lot more work than is necessary here. I can also think of 3 over x as 3 times x to the power -1 and use the power rule, so that would be a little bit easier. Or if you've memorized that the derivative of 1 over x is -1 over x squared, and this is just 3 times 1 over x. So the derivative is 3 times -1 over x squared, or -3 over x squared. So on the numerator, we have -3, and in the denominator, we have, I'm going to put the x squared in front, so we have x squared times 1 plus, and then 3 over x squared is 9 over x squared. And now I'm going to go ahead and distribute this x squared because it's going to simplify that second term there nicely. So this is -3 over x squared plus 9. Okay, if we want to work this out the long way, we write u equals our inside function, so 3 over x, and then y equals tan inverse of u. Then I take the derivative of my inside function du dx, and that's equal to -3 over x squared. I take the derivative of my outside function with respect to u, and that's 1 over 1 plus u squared. And then I substitute in for u the 3 over x, so I get 1 over 1 plus 3x squared, and I multiply the derivative of the inside function times the derivative of my outside function, which will give us the same result we had on the left. Number 64, let f and g be differentiable functions whose values are given in the table below. Find the value of f inverse prime of 2. This is a 3-step process. So for the first step, we're going to figure out where does f equal 2. That's the value of f inverse of 2. Where does the function f equal 2? In my table, so in other words, I want to know f of what is equal to 2. In my table, here's f, and I can see that it's equal to 2 when x is equal to 1. Okay, so that's the value I'm looking for in step 1. X equals 1. And then in step 2, I'm going to evaluate the derivative of f at the value we obtained in step 1. So I want f prime of 1. F prime of 1 is equal to 3. And then finally, step 3, we're going to take the reciprocal of that value. I want 1 over f prime of 1. So that's going to give me 1/3 for my final answer. The derivative of f inverse at 2 is equal to 1/3. Now part B, find the value of g inverse prime at 1. So step 1, we want to know where does g equal 1. So g of what value is equal to 1. So we look in our table at function g, it's equal to 1 when x is -3. Okay, so x is -3. And then I'm going to take that value and substitute it into the derivative of g. So step 2, I want g prime of -3. G prime of -3 is equal to -1/2. And then step 3, we're going to find the reciprocal of that value. So 1 over g prime of -3 is -2. So our final answer there, -2. Part C, find the equation of the line tangent to the graph of g inverse when x equals -2. So I want the tangent line to the graph of g inverse. And to get the equation of the tangent line, I need to find two things. I need the slope and I need the point of tangency when x is -2. So I need to find g inverse of -2, and I need to find g inverse prime of -2. Okay, g inverse prime of -2 gives me the slope of my tangent line, and g inverse of -2 is going to give me the point of tangency. So let's start with g inverse of -2. That means where does g equal -2? Because g inverse of -2 On the inverse equation, -2 is the input. That makes it like the x-coordinate. And that means on the graph of G, it's the y-coordinate. So we want to know, where does G have a y-coordinate equal to -2? So here's where G is -2, and that's at x equals 2. Okay, so G inverse of -2 equals 2. And then we need to find the derivative of G inverse evaluated at -2. So here we need our three-step process. The first thing we do is set G equal to -2. So G of what is equal to -2? Well, G equals -2 at 2. So x equals 2 is that value we're looking for. And then step 2, we're going to substitute that into the derivative of G. So we want G prime of 2. G prime of 2 is -6. And then step 3, we're going to take the reciprocal. So 1 over G prime of 2 is -1 over 6. Okay, so now I have the point of tangency is -2, 2. So my point, -2, 2. And then the slope of my tangent line, -1/6. So my equation would be y minus 2 equals -1/6 times x plus 2. Part D, if h equals g of f of x, what is the equation of the line normal to the graph of h when x equals 2? So here we need the value of h of 2 to get our point of tangency, and then we need to find h prime of 2 to get the slope of the tangent line. So h of 2 is g of f of 2, and f of 2, nope, not there. F of 2 is -3. So we want g of -3. G of -3 is equal to 1. Okay, so that tells me my point of tangency is 2, 1. Now I need to find h prime of 2, but before that I have to find h prime of x, and then we'll substitute in the 2. So h prime of x, we're going to use the chain rule. Here's h of x. H is g of f of x. So the derivative of g of f of x is g prime of f of x times f prime of x. H prime of 2 will be g prime of f of 2 times f prime of 2. So we want g prime of f of 2, and f of 2 is -3. So g prime of -3 times f prime of 2. F prime of 2 is 2/5. G prime of -3 is -1/2. So -1/2 times 2/5 is -1/5. That's the slope of my tangent line. So I have my point and my slope of my tangent line. Slope of the tangent is -1/5. We're asked to find the equation of the line normal. So the slope of the normal line, it would have the opposite reciprocal slope, so +5. Okay, so we're not going to use the slope of the tangent line. We'll use the slope of the normal line to write our equation. Then our equation, y minus 1 equals 5 times x minus 2. 65. Let f of x equal x cubed plus 7x plus 2 and g of x equal f inverse of x. Find g prime of 10. So we want to find the derivative of g, and g prime of x is really just f inverse prime of x. So the g prime of x is just an easier notation to use than f inverse prime of x. But what we're looking for is the derivative of f inverse evaluated at 10. So we're going to use our three-step process. The first step is to figure out, where does f equal 10? So what we're really looking for is f inverse of 10. What is f inverse of 10? And that means f of what is equal to 10. So we set f of x equal to 10 and we solve. So we get x cubed plus 7x plus 2 equals 10. Now, if you're using a calculator, you can solve this graphically. If you're not, then we're just going to use guess and check. So try simple values for x, like 0 or 1 or -1 or 2 or -2. In this case, if we let x equal 1, we get 1 plus 7 plus 2, which is 10. So x is equal to 1. So now we know f inverse of 10 is 1, or in other words, f is equal to 10 when x is 1. We want to evaluate the derivative of f at 1. So step 2, we're going to find f prime of 1, but first we have to find f prime of x. F prime of x is 3x squared plus 7. And now we take our answer from step 1 and we substitute that into the derivative of f. So we get 3 plus 7, or 10. Now step 3, we take the reciprocal and we get 1/10. Number 66, let f of x equal e to the negative 2x minus 9x cubed plus 4, and g of x equals f inverse of x. Find g prime of 5. So the derivative of g is the derivative of f inverse. So we're going to use our three-step process. First, we need to find f inverse of 5. So that is asking, where does f equal 5? For what value of x does f of x equal 5? So we need to take our equation for f of x, the negative, or e to the negative 2x minus 9x cubed plus 4, and set that equal to 5. Now we can solve this graphically on a calculator, or without a calculator we can try guess and check. We can try simple values for x like 0 or 1 or -1 or 2 or -2. If we try 0, I get e to the power 0 minus 0 plus 4 equals 5, which is true since e to the 0 is 1. So that is my solution. X equals 0 is my solution. So f inverse of 5 is equal to 0. That's my answer from step 1. I'm going to take that and substitute it into the derivative of f for step 2. So let's find the derivative of f. F equals e to the negative 2x minus 9x cubed plus 4. The derivative of e to the negative 2x is e to the negative 2x times -2. Then I have minus 9x cubed. The derivative of 9x cubed is 27x squared. So minus 27x squared. And then the derivative of 4 is 0. So now, my notation, that is the derivative of f prime of x. Now we find f prime of 0, the answer from step 1. So -2 times e to the power 0 is just 1, minus 27 times 0 is 0. So this is just -2. That's my answer from step 2. And then step 3, we're going to take the reciprocal. So -1/2 is my final answer. 67. Let f of x equals 7x cubed plus the natural log of x cubed, and g of x equals f inverse of x. Find g prime of 7. So the first thing we need to do is set f of x equal to 7. Okay, that tells us f inverse of 7. We want to know for what value of x does f equal 7. So we let 7x cubed plus ln x cubed equal 7. Okay, so let's guess and check here. If x is 0, I get an error because you can't find the natural log of 0. You can't take the natural log of a negative number either. So next I'm going to try x equals 1. If x is 1, I get 7 plus the natural log of 1 cubed. The natural log of 1 is 0. So I get 7 plus 0, or 7. That's the solution that works. X equals 1. If this is calculator active, you can solve that graphically. Okay, so f inverse of 7 equals 1. That's my answer from step 1. Step 2, we're going to evaluate the derivative of f and then substitute in our answer from step 1. So f prime of x, the derivative of 7x cubed is 21x squared. And then we need the derivative of the natural log of x cubed. We need chain rule for this derivative. This is stuff cubed. The derivative of stuff cubed is 3 times the stuff squared times the derivative of the stuff. So 3 ln x squared times 1 over x. Now we evaluate that at 1, since that was f inverse of 7. So we get 21 times 1 is 21, plus 3 times the natural log of 1 squared. Well, the natural log of 1 is 0, and then times 1 over 1. So I have 3 times 0 times 1 is just 0. All of that drops out. So we just have f prime of 1 equals 21. And then step 3, we take the reciprocal. So 1 over 21 is my final answer. Let f of x equal 10x plus the arctan of x squared, and g of x equals f inverse of x. Find g prime of 0. So first we need to set our equation for f of x equal to 0 and solve. 10x plus arctan x squared equals 0. Okay, so we can do this on the calculator, or we can try guess and check. If I let x equal 0, 10 times 0 is 0. The arctan of 0 is 0, and when I square 0, I get 0, so that is a solution. Okay, x equals 0. So f inverse of 0 is 0. That's my answer from step 1. Step 2, we need to find our derivative, f prime of x. The derivative of 10x is 10, plus the derivative of arctan x squared. We need chain rule for this. This is stuff squared. So derivative of stuff squared is 2 times the stuff to the power 1 times the derivative of the stuff. And the derivative of arctan x is 1 over 1 plus x squared. Now we evaluate our derivative at 0. So get 10 plus 2 times arctan of 0 is 0 times 1 over 1 plus 0. Okay, so 2 times 0 plus, or 2 times 0 times 1 is just 0, so that drops out, and we get 10. Then step 3, our final answer is the reciprocal 1/10. Number 69, let f of x equal x to the power 5/3 times e to the power x squared, and g of x equals f inverse of x. Find g prime of e. So first we need to find where does f equal e. So we're going to set x to the power 5/3, e to the power x squared equal to e. Okay, so you can solve this graphically on your calculator, or we could try guess and check. If I try x equals 0, on the left-hand side I get 0, so that doesn't work. If I try x equals 1, on the left-hand side I get 1 to the power 5/3, which is 1, times e to the power 1, which is e, so that works. That is our solution here, x equals 1. So I know f inverse of e equals 1. Step 2, we're going to find f prime of x. Now my f of x is x to the 5/3 times e to the x squared, so I need product rule in order to find this derivative. Product rule tells me to take the derivative of the first, so I'm just going to write out the form before I actually take the derivative. So I need the derivative of the first times the second plus the first times the derivative of the second. So the derivative of x to the 5/3 is 5/3 x to the 2/3, and we're going to multiply that by e to the x squared, plus x to the 5/3 times the derivative of e to the x squared. Now, e to the x squared, we need chain rule to find that derivative. That's e to the power stuff. So the derivative is e to the power stuff times the derivative of the stuff, and the derivative of x squared is 2x. So there's my equation for f prime of x. Now I need to find f prime of 1. I substitute in my answer from step 1. So that will be 5/3 times 1 to the power 2/3, which is just 1, times e to the power 1, plus 1 to the power 5/3, which is just 1, times e to the power 1 times 2 times 1. So 5/3 e plus 2e, and those are like terms. We can think of that as 5/3 e plus 6/3 e. So we get 11 over 3e. And then step 3, we want the reciprocal of that. Let me write this as 11e over 3 to make it easier to see the reciprocal. So the reciprocal would be 3 over 11e. And number 70, let f of x equal negative e to the negative 3x over x squared plus 1, and g of x equals f inverse of x. Find g prime of negative 1. So step 1, we want to know where does f equal negative 1. So negative e to the negative 3x over x squared plus 1, we set that equal to negative 1. Now we can solve graphically. We can try guess and check, although this looks pretty complicated right now. I might want to simplify it a bit first. I can multiply, well, first of all, I can multiply both sides by negative 1. That'll help because this will become positive and then that will become positive. And then I can multiply both sides by x squared plus 1. So that's going to be e to the negative 3x equals x squared plus 1. This is just going to help me do my guess and check a little easier. And in fact, let's make a positive exponent on the left-hand side. So 1 over e to the 3x equals x squared plus 1. Now, if I try letting x equal 0, I would have 1 over e to the power 0. E to the power 0 is 1, so I'd have 1 on the left-hand side. And when x is 0, I also have 1 on the right-hand side. So that's my solution. Got lucky on my first try. X equals 0. Okay, so we know that f inverse of negative 1 equals 0. Then for step 2, I want to find f prime of x. F of x equals a function divided by another function. So I start out using quotient rule when I take my derivative. So I need derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. And I could try and simplify this, but I'm just going to end up substituting in 0 for x. So I'm going to go ahead and do that right now. There's no need to simplify first. I can go ahead and do my substitution now. Oh, no, I can't because I haven't taken my derivative yet. Hang on. So I took the derivative here, but I didn't actually take the derivative here. Okay, the derivative of negative e to the negative 3x. That's negative e to the power stuff. So my derivative is going to be negative e to the power stuff times the derivative of the stuff. And the derivative of negative 3x is negative 3. Okay, so now we can substitute in the 0, or we could simplify this a little bit first if we wanted to. I'm just going to go ahead and substitute in the 0 now. So I'll have negative e to the power 0, which is negative 1, times negative 3, times, and I'm substituting 0 in for x here, so that just gives me times 1. Okay, and then minus negative e to the power 0 is 1, so negative 1, times 2 times 0 is 0, and negative 1 times 0 is 0, so this all just drops out, over 0 plus 1 is 1, squared is 1. So I just get 3. And then step 3, we take the reciprocal, so my final answer is 1/3.